Hello students, welcome to Edupedia World. My name is Shivam Mishra and I am a BTech from IIT JEE. Today we will be discussing the solutions to IIT JEE Advanced 2014 Chemistry Paper 1. The paper code which we are using is 5. So in case you have the code, you can follow the questions from there. Okay students, let us look at question number 15. Question number 15 is a very interesting question from organic chemistry and it tests us on a number of concepts. Let us have a look at this particular question. It says that all possible isomeric ketones including stereoisomers of molecular weight 100. Okay, so first of all let us consider all possible stereoisomers, including the stereoisomers, all possible ketones which have molecular weight 100. For the sake of simplicity, I am only considering open chain ketones, right? So let us first try to figure out what all possible ketones we can draw which have a molecular weight of 100. Now if you look at the formula, general formula of ketone, it is CnH2nO, and if you try to calculate the molecular weight using this, you will get 12N for carbon, 2N for hydrogen and 16 for oxygen. Fine. So, and if you put it equal to 100, on solving the equation we get 14N equal to 84. So that will make N as 6. So we have to consider 6 carbon atom chain and we have to draw all possible ketones including the stereoisomers. So first let me consider what all possibilities can I have for a 6 carbon chain. First I am drawing a straight chain. So here are 3 carbons, 4, 5 and 6. This is the first possibility. I am again drawing another one, 3 carbons, 4, 5 and 6. So 2 I have drawn straight chains. Then I will consider branching. If I consider branching, 1, 2, 3, let there be one branch over here, branch chain 3, 4 and 5. So one possibility will be this. I am again redrawing this chain, 3 carbons, 4 and 5, branch over here. Similarly, I can also consider 3, 4 and 5. I can also consider a branching at this position. Okay, and finally I can consider a double straight chain of 4 carbons, 1, 2, 3, 4 and a double branch chain. Okay, so these are the 6 possible carbon chains which I have drawn. I could have also considered for a moment a 6 carbon chain of this type. However, I am not drawing it over here because this particular chain would not have given me any ketones, because as we all know that ketones have to occur in the middle of the chain and they cannot be at the terminal positions. Okay, so now if I start and place double bond O over here, we will get one double bond O at this position. This will be my first ketone. Similarly, I can place a double bond O here. This will be my second ketone. Similarly, I can place one double bond O here. Third possibility, one double bond O here. Fourth possibility, double bond O cannot be at this position because this will make it aldehyde. So these two are identical. So one double bond O here. And finally, in the last structure, one double bond O here. Okay, I'm just going to name these structures as well. So let us call this A, let us call this B, let's call this C, this one as D, this one as E and this one as F. Okay, so these are the 5 possible skeleton structures for ketones which we can draw. Now mind you, we have been also asked to consider the stereoisomers separately. So now what we need to do is we need to check for, this is what makes the problem very interesting. Now what we need to do is that we need to check for chirality in all the possible structures which we have drawn. So if you look at structure A, there is no possibility of a chirality because there is no chiral carbon. So A won't be there. Similarly, B does not have any chirality. C, methyl, no chiral carbon. If you come to D, in D we have methyl, so here also we don't have any chiral carbon. If I come to E, now E is a very interesting case, because in E what is happening is that this particular carbon has a methyl group and an ethyl group attached to it. So clearly this is a chiral carbon and it will have two isomers, both R as well as S. So here we will get two structures and both are being reduced with NaBH4 separately. And finally in F we do not have any chirality because this carbon has two methyl groups. So now what we need to do is that we need to reduce each of these structures separately with NaBH4, and in the E case we have to consider both the stereoisomers independently, and then we have to decide which ones of those are going to give a racemic product. So let me consider each one of them one by one. Let me draw structure A first. In structure A we had an open chain without any branching, straight chain of 1, 2, 3, 4, 5 and 6 carbons, and a double bond O was fixed at this position. This was my structure A, okay, and this was being reduced with NaBH4. So NaBH4, a reduction will lead to formation of an alcohol. So 3, 4, 5 and 6 carbons, and I will get an OH over here and an H over here, okay. In the product clearly we can see that this particular carbon is going to be a chiral carbon. Now you all must remember that C double bond O is a planar structure, it is sp2, and H minus hydride attack can take place from the top as well as from the bottom, okay. So for this particular carbon at this chiral position we are going to get both R and S. There is a racemization tendency like it happens in SN1 reaction, similar sort of a thing. So we are going to get both R and S over here and the probability of them will be equal. So clearly this particular ketone is going to give me a racemic mixture. So A is going to be my answer. I am going to count this as one of the products. Now let me look at B. If I again draw B over here, the alcohol B was of 6 carbons, 1, 2, 3, 4, 5 and 6, and I had put a double bond O over here. So similar sort of a story is going to be repeated. This is my B structure. Similar sort of a story is going to be repeated here, because if I draw the product for you, 3, 4, 5 and 6, and clearly the product will have one OH and one H. So this carbon again is going to be chiral, so this will also give a racemic mixture. So B is also going to be my answer. Fine. Let us look at C. C structure was this. If we again draw the product for C, there was one branching over here, 1, 2, 3, 4, 5 and 6 carbons, and here it was double bond O. If I draw the product for this, we will again get a chiral carbon, OH and H. So this chiral carbon will again be a racemic mixture, similar sort of a story. Similarly you can visualize for D as well. If you put, if I am just drawing the product here only, if you put one OH here, you remove this bond, you put one OH here and one H here, you will again get a chiral carbon over here. So A is going to be my answer for racemic mixture, B will be answer, C will be answer, D will also be my answer. So we have 4 so far. Let us consider F. In case of F, again I am drawing the structure here. If I put one H over here and I am just removing this bond and put an OH over here, so again this carbon will be a chiral carbon, you can see it over here. So this again F will also give you a racemic mixture. Fine. So we have 5 so far. Let us consider E. In E, this particular product itself has 2 isomers, okay, which are either R or S. And if I just redraw it again for you on the next page, if I separately consider E, okay, so if we consider E separately, See, E structure was this. And if I put a double bond over here, see, this was my E structure, and this had a chiral carbon, and it could be R or S. Fine. So if you draw the product for this, now what's going to happen is, see, you are making to react both the stereoisomers separately. So if I draw the product for this, there will be an OH here and H here. Fine. And this carbon was chiral previously. In addition to this, what is going to happen is that this carbon is also going to become chiral. Fine. So what happens is that racemization takes place at this position. That is, you will get both R and S at this position. But for this, you are making both of them react separately. So you will have either R or S. Fine. So the resultant product is definitely not going to be racemic, because at only one of the positions racemization is taking place. So it will not be a racemic mixture. So finally my answer to this particular question will be, if I just go back and visit the structures again, will be A, B, C. A, B, C, this one is D and F. These are the 5 ketones which will give you a racemic mixture. So the correct answer to this question will be 5. Thank you.